Hello and welcome to this Swift programming video. In this video I'm going to show you how to convert a number, or specifically an unsigned integer with 8 bits, to a binary string. Now you could do this for 16-bit or 32-bit and so on, but this example is just going to use 8-bit to keep it nice and simple. So with that said, let's just jump straight in. So first of all, we're going to create an extension on uint8. And we've got two properties here. We've got bits and then we've got binary string. The binary string is doing something super simple. It's taking this array of uint8s and then it's just mapping over to make a string, and it's joining them together to make a string. That's nothing new, okay? And we can even remove this return statement. There's nothing new. You'd have learned this a long time ago already, okay? But the question is how do we split up this 8-bit integer now into the bits that we want? All right, well, okay, first thing we want to do is we want to create a closed range, okay, by saying 0.7. If you don't know what a closed range operator is, then it's video number 24 in this playlist. We first want to have a closed range operator, and then we're going to map through each of these numbers. Obviously, this is going to be 0, 1, 2, 3, 4, all the way through to 7, which are all of the bits that we want to concentrate on. However, because binary goes to the most significant bit first of all, and let's just write this out. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So this 0 here, the furthest left is the most significant bit, and the one furthest right is the least significant bit. So as we know here, we have 1. Let's just go over this first of all. We have the values of 128, we have the values of 64, we have the values of 32, we have the values of 16, the value of 8, the value of 4, value 2, value 1. Okay, so 1 is then, and let's just go over this first of all. This is then 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. Okay, and we missed that one in the wrong place. Obviously, 2 to the power 0 is 1, 2 to the power 1 is 2, and so on all the way up to 128. So we want to be able to access this bit first to append it to this one here. All right, so the first bit that we want to be doing is this one here. So to do this, we use then the right shift, and we want to take this bit and we want to move it all the way over to the right hand side to test whether this bit is a 1 or a 0. Okay, and if it is a 0, then it's just going to be a 0 in here. If it's a 1, it's going to be a 1 in here. All right, so we now say self because we're testing self, and we're going to right shift it, and that's used then with the two greater than signs or the angle brackets, and we're going to right shift it. We need to go then 7 bits all the way to the right. Well, at the moment our first one's going to be 0, so we're going to have to just then say 7 minus, right, and then whatever this number is going to be. And obviously when it gets to 7, it's going to be 0, which is the correct bit that we want to right shift, and we don't want to right shift the 7th bit at all. Now, in order to be able to work out what number we want on there, we now have to do the AND operator to work out whether it's on and off. So we use the AND operator, and we're just going to AND it against 1 bit, okay? And so it means that if that final bit now is 1, then we're going to return 1. If it's 0, obviously 1 and 1 is equal to 1, and 0 and 1 with an AND is equal to 0. So, and 0 and 0 is equal to 0 as well. So this is going to give us then 1, right? So once we've got that, we can now get rid of this return statement because we don't need it, and we run this, and you will see we get 0, 0, 0, 0, 0, 0, 0, 1 as expected. So let's move it up to 2. And we move the bit 1 going up. Let's move it to 4, and we move it up again. Let's move it to 3, just to show you that we get the first 2 bits. Let's move it to 8, and we show you get that. And let's move it to 7, and you show that it all works. All right. Let's go to 16, and we move to the next bit. Let's come back down one again, come to 15. You see we get the 4 bits, and you can skip through this if you want, but we go to 32. And then we come to 31 to show you we get all bits activated once again, and nearly finished 64. And then we come to 63 to activate all of the lower bits, we do. And then 128 to activate the final, the most significant bit, and to show all of the other bits are activated, we go to 127 and we have them activated as we'd expect. All right, so this is the way that you can, I mean, this is really the most efficient way, using the standard Swift ways of doing it, that you can convert a uint8 2 bits and then turn it to a binary string. You could start going into the unsafe areas to possibly do it even faster, but I think you would be talking about like thousands of a second's difference between speed here, or even, I don't know, but this is already pretty fast. All right. With that said, I hope that you've got something out of this one video. There is another way of doing it, but I don't see that is actually a very nice way. And if we just say binary string 1 here, and we say then string, and we say then number, and radx is 2, and then we can say binary int is here, and we'll just say binary int and binary string, and we need to force unwrap it. And now we can say print, and we say string format, and we take then the format that we want it, which is going to be then 08, and that's going to be a decimal. And then we take the binary int as here, and we run this. You can see we get exactly the same thing as well, and we run 2, but it's not very clean. I mean, this is a lot cleaner because you get the bits first of all, and then you get the binary string. It's a lot cleaner. So my advice to you would be to learn about what closed range operators are. Obviously, video number 24, and then this is then showing you how to right shift. Right. So let's just go over this once again. If you didn't fully understand this right shift, then if we said then num right shift 1 here, right, this 1 here is going to move to the right 1 bit. So it would mean that it would then add a 0 onto the end first of all, then it would shift that bit 1, and it would shift all of the other bits, so 4, 5, 6, 7, 8, would shift the final bit off, and it would throw it away, discard it, completely discard it. And then if we would do then right shift 2, that would add another 0 onto would take the most significant bit and add a 0 onto, or basically add a 0 onto the end, making the most significant bit the not most significant bit any further, and it would discard the least significant bits once again. Now, right shift and left shift, they do the same thing, but they're just starting from the other direction. They will add the 0 onto the least significant bit instead. All right. Now, if you were working with the signed ones, and the most significant bit was 1, then it would add 1s on the end. All right. If the most significant bit was 0, it would add 0s on the end, because this is the signed bit on the end. Okay, so that's just another thing for you to understand if you are working with signed integers instead. Okay, with that said, I added a little bit more of a golden nugget on the end with regards to right shifting, and then we looked at the the bitwise AND operator as well. With that said, thank you very much for watching. I hope that you've got something out of this one video. Don't forget to like, subscribe, share, and if you've got any questions, feedback, or concerns, then let's put them in the comment section down below. This video showed you how to convert a number to a binary string, or a unsigned integer with 8 bits to a binary string. Thank you very much for watching. My name is David Thorne. Ciao, ciao, and goodbye.